I'm not sure if you're able to see me. Oh my. Yes. Oh, hello, everybody. We are here to solve exercise 5.10. Right? Exercise 5.10. Write a function fibs that generates the infinite, infinite, infinite list of Fibonacci numbers. And there is this series of numbers. And that's all she wrote. No, no, we don't have some type signature for this one. So, and by the way, all these exercises might qualify to be hard exercises. They are not trivial. I don't know. Maybe you are an expert. I don't know. Maybe intermediate. Yes. Oh, time flies. I remember yesterday we did solve from. Look, we did have this problem. It's okay, but the one this is not okay. Well, this is okay. Once, where is this thing? Okay, here, because we went over here above. Mm, the problem. Okay, with what problem? Let's put this back down below. There is an order. We use take while. Well, we were using take at the beginning. Take five, and we did found this behavior. We found we found this behavior. Early these days, I probably at this point probably I have said this like I don't know how many times I go with my mother to the hospital 3 times a week. So in the waiting time when I'm waiting for her, I took the time to since this is online. I took 5 minutes because I wanted to listen to music instead. Um, take a look of what was wrong. Where is take? Mm, here. So we're calling take. We're recursing with take, but we are not using the tail. We forget about this. So be careful with this one. Now we got the solution 1000, 1004. We will put a note on exercise on the live session of, for exercise 5.2. So people seeing that video and spotting the problem will take a look at the description and say, oh, this was solved on 5.10. It was solution was shown. Now, Now back to the exercise after 5 minutes. Write a function fibs that generates the infinite lazy list of Fibonacci numbers 0, 1, 1, 2, 3, 4, 5. Since there is not any type signature, we can put this thing inside the companion object, but fibs is not an utility function uh, for my lazy list. So perhaps this function will end living down below here. But we will use the approach. I can't believe how time flies. By the way, I'm not sure if I will continue with this series because maybe only on Sundays. We will see because I need to take I need a job, and if people are wanting some other technologies, I shall study those and stop this. Maybe on Sundays, I don't have to stop this series at all. Okay, Fitz. Again, back to our topic. We will use this approach. Cons, some, you know, building a lazy list and then recursing this, and also from building a lazy list and recursing. Okay, let's write this function down below here and see what happens. The fibs fibs will return on my lazy list of int. Remember, these numbers explode, like are become bigger very fast. So at some point, this thing will overflow. But we are only exercising some of them to show the mechanics. The lazy list. Now, how can we implement this function? Mm, We will need some kind of helper function for like some like this from to have a starting point. Uh, so let's define it over here. Uh, Fibonacci's uh, and let's find starting point. Start int and it will return a lazy list. Type int. Okay. Now we need to use these Fibonacci's. Let's give starting point 0. That's all. $11. 11 minutes. I'm not sure if this is going to work. Can we use counts? Yes, because we are importing everything. Fibo. What Fibo you will say? You might ask. Well, it's so an existing function that we are going to write and called fibs. No, Fibonacci's with start to 1. This should make it. Now it is time for us to write people. Left of people and int the return int equals to something. 30 minutes. Allow me to write this function people on the Scala repo in my computer. I don't know why. Feel more secure. I don't know. You know. The people and int will return an int kind of station rec um, loop. I think I need my notebook. Yes. Okay, the first one is 0 and the second one is 2. So we need ACC1. Let's hope for the best. The int ACC2, the int, and what else do we need? 2 int, 2 int, and what else do we need? 2 int, 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 um, and type int. We will return an int, and we will say if n equals. Here we have. Lately, I like counting. Where are you? I like counting starting from one because I'm doing some math review. Well, in computer science, most of the time we start from zero. Unbelievable, 16 minutes. Need to continue. Probably I will start a podcast since I, uh, to use my time when on the road, traveling from this my small hometown to the city in which the hospital is located. I need my log. These two cases are quite trivial. And then ACC one, we will call loop my approach when solving these things. And remember, we did fail this when we started this series. We weren't able to solve this apology because I got too nervous. We ended looking at the answer. I remember several months ago. You know we are live. Probably, I remember it was the first one, 4 months ago. Now we are on 5.10, 19 minutes. If n equals 1, then h is 2 else. I certainly made my notes. Sorry about this. Where is the pen? No, maybe we can exercise it over here because I don't have the one that it like thing is more like okay. Let's use this. Let's suppose we okay annotation. Correct. Let's define loop with this local loop. Uh, okay, the first one is here. The second one is this. And let's and okay. Nth is the one that we is the one Fibonacci number that we want to calculate. So let's suppose nth is 0. Let's suppose nth is 0. So we return 0 and equals 0, then ACC1. ACC1 is 0. Okay. Let's suppose n is equal to 2. To 1, sorry. Then we return this. Let's suppose nth is equal to 2, which will be the third Fibonacci number. Then what we need to do is remember n, which is the 3. We look something like this loop. Uh, some question mark. Since we want to calculate this, which is the 2, well, in fact, it is the 3, the third number. We need to sum these two. We need to sum these two, ACC1 and ACC2. And someone will say, why are you summing these terms on this parameter instead of summing up over here? Well, it is because uh, we are we are about we are on the 2 n equals 2, and we are about to recurse our loop, you know, call again loop, but we with one less, like this. So that number, this n, which is 2, will now become 1, which is this condition, and we will return in the sum of these two, which is 1. Okay, now we need to figure out what's going on in here. What's going on in here? Yeah, let's take a look at the book. Let's suppose now that we are on n equals 0, 1, 2, 3, yeah, we need to sum these two, 1 So the first parameter will have to be ACT2 because we have just uh, add that number, and then loop 0, 1, and sorry, and which is this, and we have our pivot. Let's start testing this function. Pivot of 0, 0, 1, 1, pivot of 2, please be 1, pivot of 3, please be 2, pivot of 4, please be 3, pivot of 5, please be 5, pivot of 6, please be 8. We got it. So this is our redemption uh, from this video in which, oh my god, I was like insane, too nervous. It is a redemption in the terms of the Fibonacci, because I knew these problems. I have solved this one like 4 or 5 times throughout my career, but I didn't memorize it, and in here this was like the first time I got it. I was like very nervous. I was just uh, doing some testing, live stream testing. Live, this is the one, two. This is the first production live. Um, then I went directly to this, and I I don't know. I somehow I experienced the thing, but it was a good learning experience. We ended up seeing the answer in my own GitHub repository, not in the book, because I have solved this 2 years ago again from other points of my life. But okay, this was Caleb solving Fibonacci live and showing the reasoning behind it, right? You saw all the thing how it was uh, construct. Now we need to put this function into work in our scarcity uh, worksheet. We're going to copy paste this. We're back. Fibonacci 0. Now we need to let's compile this. Okay, it worked. Now let's fix. Take uh, take 5, lift. Let's take 7, and we got the series that the book is asking for 0, 1, 1, 2, 3, 5, 8, 0, 1, 1, 2, 3, 5, 8, 0, 1, 1, 2, 3, 5, 8, 0, 1, 1, 2, 3, 5, 8, and this is the infinite Fibonacci numbers. We were able to use this approach that they show in the book, like once, then we solve continually, and then we solve from, which is from. You are constructing. This is a good book, you know. This is how you, the best way, in my opinion, to grow. Start very easy, the most easy, simple thing you can solve, and start adding complexity over that over that base. So we are done for now. Weekend. Happy weekend. Uh, I was nervous, to be honest, because we script this thing at the beginning, but now we were able to shine. Okay, to solve things. And thank you very much. Happy weekend. See you with the next exercise on Monday. Well, I don't know. Perhaps I'm not sure if I'm going to talk about this. The weekend, most likely not, because I would like to do other things. I would like to find ways. I would like to find a way to come up with some days ago I came with a solution that worked, provided a solution as a means of an extension, a web browser extension. Yeah. Happy weekend, and thank you very much.